Hi everyone, welcome back. This is the second video for our unit of plate tectonics. And what we're going to be looking into on this video is how the convection currents actually work, right? On the previous video that we saw a couple of minutes ago that I sent, we it was more geared into understanding what density was, right? But this one is going to be more into the convection currents itself. So let's start by looking at this video right here. All right, I'm going to pause the video so you can see what this guy is looking at. He's putting over here on the bottom, you can see that he's going to be adding a chemical potassium permanganate, right? So it's potassium, it's a metal, so it's going to be denser, it's going to sink when he put him on the water. Let's take it out. All right, so there you go. You can see how the potassium permanganate is going to be solid because it's denser, it's heavier than the water. So if it's heavier than the water, it's going to be sinking, right? So this is very important. We are going to be moving this video forward. So you can see he's going to be fire the candle, right? It's going to light it up, and then it's going to heat up the water. And let's see what happens after that. There you go. I fast forward a couple of seconds, and you can see with the heat, all those molecules of potassium permanganate are going to start separating. They're going to be separating. They're going to be becoming lighter. The density is going to be lost. So we have less density on that chemical, which is going to make the or the chemical to rise to flow. Because since you are separating the molecules, instead of having all those molecules together, uh, denser, right? They are going to lose density because the molecules are going to be spreading apart and they're going to be occupying less space. So this is what happens. They're going to be rising up to the top. Anything that is hotter tends to go up, and air that is hot it rises up. Okay, so let's take a look at another video that I have there. This one actually has about three things going on, right? So let's take a look at it.
Take a deep breath. Get ready for one of the most hypnotic things you'll ever see in a science class. Have you heard that heat rises? Well, here you can see it's true for yourself.
Same thing over here. This guy has, I believe, right here. So you can see here he's adding heat underneath this cup. He has, I guess, a candle where he's heating up the water. And as you can see, this is like food coloring. It's gonna start rising up.
Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up.
All right, so this is exactly what happens inside the mantle of the Earth, right? So inside the core of the planet, we have heat, right? It's a lot hotter the deeper you go into the Earth, right? So that heat is going to make this will be like, for example, it can be like the mantle of the Earth. So from the inside or the bottom or the inside of the core of the planet where the heat is coming from, the area that is there or the magma that is there gets hot and it's going to start going up because it loses density. As they become less dense, right, they're going to be floating.
Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides.
All right. So as you can see here, and this is exactly what happens on the mantle of the Earth. When the magma that is very hot because it's closer to the core of the planet rises, and once it goes all the way to the top, it's going to spread to the side. It's either going to be spreading this way or this way, all right? And notice that more magma is going to be drawn, like he's saying right now, which is represented by the blue. How the blue over here on the side is going to be sucked in into this area where the magma is rising, right? This is going to create this convection currents, and those convection currents are circular in motion, all right, or in pattern. As you can see, those are going to be turning like this in circles, or here in circles like this, where the area that is very hot is going to be going up, and then as the magma travels, or this food coloring or water that is hot travels, it's going to be cooling down. And as it cools down, eventually the density increases, or it becomes denser, and then it's going to fall due to gravity. Gravity does the work over here when objects are heavy, right? And this is what is happening to this area of the water after traveling all this area and being cooled down. It becomes denser, it becomes heavier, and then drops to the bottom.
You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle.
All right, so he basically explained everything that I just mentioned, except that he did not mention density. But remember, like on the previous video that I explained the principles of density, this is actually what's happening. Okay, the reason why, remember, Alfred Wagner couldn't explain why um, these continents were moving. And this is the reason why. Those convection currents, it has to do with density. This is the reason why. Okay, objects that are dense, they become heavier and they fall. Objects that loses density, they become lighter and they float, right? So this will be the example of what's happening to magma inside the mantle of the Earth.
These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water.
All right, so I'm going to stop it right there because he's going to be relating these principles on this video to ocean currents, right? But that's a different topic. And the principle works exactly the same because it's going to be due to density. All right, so let me pause that one and let me find another video. I believe the other one is um, bigger convection currents of rice. So I'm going to be typing this one and I'm going to look it up, and here it is. I want you to take a look at this. This is the one that we were going to be looking into in the classroom. We were going to be doing this one. Obviously, we're not in the classroom. We're not going to be able to do it anymore, but I want you to pay attention to it. This is slow motion, as you can see. Okay? Notice how the rice is going up this section, but it's also turning. It's falling, right? As the rice gets hot, it goes up, it loses density, it goes up, then it moves, it slows down, and then it drops, right? So that's basically what we have. I believe that this one is the same one too. Um, that's about it. Anyway, that has to do with how the convection currents will make everything, all the plates on top of the crust of the Earth, to move.